So sometimes in Go you'll find yourself needing to interface with a database, maybe a small database like SQLite for some sort of local storage, or maybe a large database like, say, Postgres or MySQL. Go itself provides a standard interface for dealing with SQL databases, database/SQL, which provides a number of functions for opening and closing databases, doing queries, preparing statements, executing them, etc. And it's an extremely easy to use interface. All you have to do is include it, import it, and also import the appropriate driver for your database. So to give an example about how this is pretty easy to do, I've created a little SQLite 3 database, and I've also written a little program that does a query on it to show you the basics of how this works. So let's just take a look at it. First of all, you're going to include database/SQL. So database SQL, that is the standard Go interface for doing it, and an appropriate driver. In this case, I'm using the Go SQLite driver by Matin, which is very widely used for SQLite 3. And I've prepared a little database file. It's called scientists.db. And if I load it up into SQLite, then I can see, if we just go, there's a table called names, and I can say, if I just pull everything out of there, so I've got Charles Babbage, Ada Lovelace, Michael Faraday, and Brunel in here, so just a few little simple names in the database. And I'm going to open that database in Go and do a query on it just to get everybody out of it, to give you the basics of how you do things. So, although we're using this particular driver here, you'll notice this underscore in the front, which indicates that we're not actually directly in this module here using any of the imports from it, so we don't want Go to complain about it. It's actually database SQL which will deal with that. And if we go down, you'll see the way this operates is that I'm doing a SQL.open here. This can be used to open any type of database. So if for SQLite, you're opening a file path because it's stored in a file. If you might be connected to, say, Postgres, which is running across a TCP socket, then you would have the appropriate connection string here, perhaps with usernames, passwords, the address of where that is. This can be used for any sort of database you're connecting to. And I'm using defer so that when the program terminates, I close out the database itself. Then I'm going to do a query. I'm just going to do a simple query here, just using db.query. It's going to give me a list of rows back, which I can then iterate over. And I'm also going to close that set of rows when I'm done. And notice, of course, that because of the ordering of defers, the rows will close before the database, so there's no worry about those being in the wrong order. And then I'm just going to do a for loop, and the for loop is going to iterate over all the returned rows. And for each row, I'm going to use this scan function. It will match each field that's been returned against one of these variables here. And if you look in the original database over here, there's an ID, which is just an auto-generated integer, and 2 strings. So doing this will actually match each row one by one into those variables. And I'm going to, for each one, just print out the first name and last name of the program, of the person. And when the program terminates, the rows will get closed, the database will get closed. So we can just go ahead and build this guy like that, and then run it. And there, it's done it. It's connected to the database, it's opened it, done the query, and printed out that information right there. So that's the very basics of accessing a database, be it SQLite or something more complex like Postgres from within a Go program. So the standard sort of database access, querying, updating, preparing statements is pretty obvious, and it's the same for every driver you're using. But it also provides the ability to do transactions, and I've just modified this slightly so that we have a concept of a transaction used here. And I also modified the database a little bit, so if we just take a look, and I have a look at the names, I added in a field at the end, a boolean, which is stored as a 0 and 1 in SQLite, as to whether any of these scientists are still alive. And inaccurately, the database says they're all alive, so obviously we're going to have to fix that in the Go code by setting those to false. So I've modified the Go slightly to bring in that boolean to see whether somebody's alive, although I'm not actually going to use it other than print it out. And I've moved that code that actually queried the database into a function called show, which will just dump out the names table, because we're going to use it a couple of times. And immediately on starting, I show the database, so show the current state of it, and then I'm going to create a transaction. And so the way you do that is you call db.begin, which starts a transaction on the database. And I'm using prepare here to prepare this statement to update everybody to have the alive boolean set to 0 or false because they're no longer alive. And once I've done that, I'm actually going to execute that so that it's done. And before committing the transaction, I'll dump out the database again to verify that nothing has changed. Then I'll commit it, and then I'll dump out the database again. So you should be able to see that twice it'll say they were alive, and the third time the transaction will actually have been committed. So let's just check that that builds. And then let's run it. So the first time show was called, let's find where that is here. It shows that everybody in the database had that field marked as true, so they all were thought to be alive. I then started the transaction, prepared the statement, executed it, but had not committed it yet, and showed the database. Again, the database had not been updated. And then as soon as the transaction was committed, everything's been updated to be false. So within the standard database SQL interface, you've got standard things you can do with queries and updating databases, inserts, updates, all the things you can do within SQL, preparing statements with fields that you can actually insert safely with the correct sort of escaping, and as well as transaction support. So really within database SQL with the appropriate driver, you should be able to access any database you need to from within Go with ease.